I don't know if I could redo this. And that was the scale we started with, right? It makes sense. Period of, y equals sine x is 2 pi. But then we changed the scale so that, now we haven't changed the size of the graph or anything. Whoops, redo. Oh man, I thought I could redo that. I'm sorry. So we're going to change this now back to making it numbers that would be nice to use, not values compared to pi. The graph hasn't moved. The scale has changed on the axis. It's just that the grid has changed size. Nothing's different about the graph. It's still sine x. Does this make sense that it ends right there? What is that value in there? 2 pi, right? It's 2 pi. That's 1 pi. If I change this to a 2, what's going to happen to the graph here? If I stop on 2, the graph still gets compressed. Everything's the same about it, other than it's now the period is pi instead of 2 pi. What I want, though, is I want to be able to scale it so that the values are, so that the thing has a nice period. What could I do with these numbers here to make it so it has a nice period? In other words, if I start at 1, what could I change that to? So say it had a period of, I don't know, 1. How could I change it so that the period's 1? How much do I have to compress it here? Do I compress it by 2? Compare it by what? I'm not gonna, so it's not gonna let me be accurate enough to do by pi, but actually that's pretty close, right? 3.1. That now has a period of almost 2. It's a bit off up here because that's not exactly pi. If the b value you use involves pi, then the scale down here will not involve pi because you've scaled out the pi. If we change this to, what's the next number I could do here? Maybe, I didn't make it so it goes high enough. What could I go up to here, though, if I wanted the period to be 1? If you did 2 pi. If you make this value involve pi, this one, the scale here won't. So that's what's happening here. Here's a relationship between the b value, the number in the function, y equals sine of bx, and the period. We already kind of looked at before lunch that the period you could find by just taking 2 pi and dividing it by the b value. Right? So if the function was sine of 2x, that b value is 2, the period is pi, right? Because you can work it out and say, well, 2 pi divided by 2 gives me the period, which is pi. If I have 2/3 of pi, what number do I have to put here in the function to get the period to be 2/3? Think of expansions, compressions. If this is 2 pi, I now want to do 3 cycles in there, right? 1, 2, 3. There's 3 cycles in 2 pi. So that the period is 2 pi divided by 3. What number goes in the equation? 2 pi divided by 3, what number goes in the equation here? I'll give you a hint. 3. It's 3. Good job. It's 3, right? Y equals sine of 3x. Maybe it's no good because you don't see here. The period is 2 pi if you haven't done anything. It's 2 pi divided by 2 if you put a 2 in there. It's 2 pi divided by 3 if you put a 3 in there. I don't have a line for this, but if you put a 4 in there, what would the period be? You take the usual period and you cut it up into how many pieces? Sorry, I'm making an extra line here. I know that troubles you. Let's see here. We have to make some connections here somehow because I'm worried that the connections are not being made. Let's go back to transformations. You had no trouble with this. F of x. If I put a 2 in there, what does that do? It compresses it by a factor of 2, right? Everything will be compressed that much. There's that if you want. If you put a 3 in there, it compresses it by a factor of 3. Everything's compressed by 3. If you put a 4 in there, a 5, a 7, it's compressed by that much. So essentially, if we are changing this from a 1 to a 2 to a 3, and then maybe to a 4, you're taking the usual period, which is 2 pi, in every single case here, and you're dividing it up amongst whatever number you're putting in there. If you did y equals sine of 38x, what would the period be? Well, without the 38, it would be 2 pi. With the 38, it's going to be 2 pi divided by 38, right? That number underneath there, that's how you get the period. The period gets crunched up into, there's 38 of them going to fit in one, right? It's 1/38 of what it is. I don't care how you look at this. If you think of this as saying, normally the period's 2 pi, but it's 1/38 the size, you could write it like that if you want, if that clicks in your mind. It's 1/38 of what it would be because it's compressed by 38. 2 pi over 38. If you have any one of these other ones here, if you have pi over 4, this is like 2 pi over 8. This is going to be 8. Okay? Y equals sine of 8x. If you put an 8 there, it's 2 pi over 8, or pi over 4. Make the fraction 2 pi over something and you can see what it is. There's a million different ways to work with this connection here, and I'd rather have you make your own way or learn your own way, make sense of it in your mind, rather than me saying, take this formula, stuff the numbers in, and work it out, because that's not going to last. You're going to know it today maybe, but not when you actually need it later on when you're using it for something else. Now, you should probably put a big, huge line here because this separates something. All of these ones involved pi. The period involved pi. Suddenly now we don't want to involve pi in the period. What do we have to put over here? If you're continuing on here thinking with, if I write this as 2 pi divided by something, I would write it as 2 pi divided by pi. If I scaled it by a factor of pi, the period comes out to 2. This is pi here. If you do 2 pi divided by pi, as in if you scale it by a factor of pi, the period is going to come out to something that does not involve pi. Okay? All of these are, since this involves pi, this doesn't, right? 2. If this is 1, what does this got to be here? What do I have to scale this by? If I have y equals sine x, and the period is 2 pi, what do I have to scale it by to get the period to be 1? You just have to divide it by 2 pi. This has got to be 2 pi. The number in the equation is the number you divide 2 pi by to get the period. It's the scale factor. If you put 6.28 in there, it would give you roughly a right number, but eventually if you went to a million cycles, it'd be way off by then. So in the equation, you're going to put one of these numbers. Okay? If this is 2 pi over 11, what is this? Remember that this is connected here, right? If this is 8, this is 2 pi over 8, right? It works the same way here. If this is pi, this is 2 pi over pi. If this is 1, this is 2 pi over 1, right? They're related that way. They multiply to 2 pi, okay? All of these things multiply to 2 pi. That multiplies to 2 pi, that multiplies to 2 pi. Maybe if we get rid of everything, you can see that better. Look at any pair of numbers there, except I erased them all. This was 1 times 2 pi. This was 2 times pi. This was 3 times 2 pi over 3. This was 4 times, this was 8 times that. Gives you 2 pi. This was pi. This was 2 pi. What's this going to be here? If the period is now changed to, if the b value is 2 pi over 11, this is 11. If this is 2 pi over 7.1, that's 7.1. The function, people have trouble because they're not used to writing a pi in the equation. This is sine of pi x. This is sine of 2 pi x, and so on here. This is sine of 2 pi over 11 x. This b value goes in there. People are troubled as soon as they're starting to write this. Essentially, if you can write the function like that, if you can write the function as sine of 2 pi over something, this is the period on the bottom there. The period is on the bottom. That's the period.